Now dear children, we will do the last topic from this chapter, and with this topic your chapter get completed. Okay. Now we again derive a relation between two velocities. That is the relation between one is called particle velocity and another is called wave velocity. Now this particular term, particle velocity and wave velocity, I had even explained in one of the YouTube video. Okay. And as I said that this wave velocity which propagate in a particular direction in a medium is not same as particle velocity. Whereas every particle acquire a velocity due to the oscillation or vibration, and the vibration acquired by the vibration as one of the motion, or oscillation as one of the motion acquired by the particles of the medium acquire a velocity. That velocity is called particle velocity. But as a result, the wave which propagate in a particular direction with a velocity, and that velocity is called wave velocity. Now, in order to derive the relation between particle velocity and wave velocity, okay, let me just start with the relation of displacement. Okay, let me just write the relation of our displacement of the particle in plane progressive harmonic wave propagating in what? X direction, or positive direction, what? X axis. And the relation is given by y equals to a sine 2 pi by lambda bracket bt minus x, where b is the velocity, okay, of a plane progressive wave traveling in x axis, a is the amplitude of the simple harmonic wave, okay, lambda is the wavelength of the wave, and x is the displacement acquired by the particle, okay, from the origin. Now this particular relation of displacement is the displacement of particle, this is the displacement particle, okay, acquire at a distance x from the origin. So this is the displacement particle at a distance x from the origin. So which is the displacement. This is the displacement of a particle, okay, at a distance, displacement of particle at a distance what? X from the what? From the origin. Now with this we can calculate the velocity of the particle. Now velocity means what? The rate of change of displacement of the particle. So I write down now thus the velocity of the particle. Now the velocity of a particle is the what? Rate of change of displacement. It is the rate of change of what? Displacement of the particle. The rate of change of displacement means actually nothing but the displacement by time. But this change in the displacement particle with time is very, very small, which can change at any instant of time. That's why we calculate this velocity of the particle as instantaneous particle velocity. What velocity? Instantaneous particle velocity. And children, this instantaneous particle velocity is actually calculated by differentiating this equation 1 with respect to t both sides. Because when displacement by time, that displacement time is our velocity, but this change in the displacement with time is very, very small. That's why this change is also called instantaneous change. Okay, so for this we follow now differential calculus. So I do differentiate equation 1 both sides. So I write on d by dt of y. So differentiating on left hand side with d by dt. I also differentiate right hand side by d by dt with a sine 2 pi by lambda. Okay, let me write curly bracket with bt minus what? X. Now I differentiate this as for the relation. Now for the differentiation of right hand side, now I follow one of the formula that you can see. It is d by dx, say of cos, okay, this is sine, okay, this is with sine mx is actually given by m cos mx. So this is a formula. Differentiation of sine mx is given by m cos mx. Okay. Now the same thing I can follow now for the differentiation of this quantity with time. So let me just write it down. Now in this particular relation, if you see, I have followed this differentiation. So m means the constant, that is 2 pi by lambda. Okay. Now a is simply a constant. We are differentiating only with this function. Okay. We differentiate with cos sine function. So differentiation of sine is cos. So a means a only. Differentiation of sine is cos. So cos 2 pi by lambda bt minus x. Now into mx, m. But this m is what? 2 pi by lambda. But when we differentiate with sine with cos, this t is also with b is also with t. So differentiation of dt is also equals to t, or dt differentiation of dt of t is also equals to what? 1, because we need to differentiate differentiation of dt with bt, and differentiation of dt of bt means what? B into 1. That's why this b is also there. So 2 pi by lambda into what? B. Okay. Now this is the displacement of particle, and this is the velocity of the particle. Okay, and this velocity is also called particle velocity of the particle. Now I'll give this as equation number what? 1. Okay, equation number 2, because I have already given equation number 1. But children, there is a relation, and when the relation is nothing but same, y equals to what? A sine what? 2 pi by lambda into bt minus x. So if this relation we follow, then we can calculate the slope of this displacement x, displacement position graph, and from this displacement position, okay, we can calculate the slope, and the slope of that displacement position also measure the what? Velocity, and this is also called the particle velocity of the particles. So what I do now, the slope of what? Displacement, the displacement curve at a position, and that position is x, is also given by dy by dx. So dy by what? Dx, yes, because when we calculate the slope, it is the slope which calculate between y versus x, because y bearing with what? X also. Okay, different position across particle has different displacement. That's why if I calculate the slope of this displacement and x, then this displacement of x slope is measured by dy by dx, and this is also calculated by differentiating this quantity d by dx with quantity a sine 2 pi by lambda bt minus x. So if I differentiate this with x as a variable, okay, then this is the slope of this dy y by x. Okay, so that's why dy by dx equals now d by dx. Now this a is constant, so I differentiate now with d by dt dx with how much? Curly bracket sine 2 pi by lambda bt minus what? X. Now this differentiation I exactly follow like same differentiation as sin mx as m cos mx. Okay, so if I do differentiate, it will be a. Now in this case also, this 2 pi by lambda is a constant, but I differentiating with x where t bt is constant. So first differentiation of sine means what? Cos 2 pi by lambda with bt minus x into, now I differentiate with this x also, but it is 2 pi by lambda into differentiation of d by dx of x is minus 1. That's why now it will be minus, okay, minus a 2 pi by lambda, okay, cos 2 pi by lambda with bt minus x. So I got dy by what? Dx. Okay, dy by what? Dx. Now what I do give this equation as equation number 3. I do give this as equation number 3. Now I divide equation 2 by 3 both sides. Now I am dividing both equation 2 by 3 both sides. Dividing equation 2 by 3 both sides. So if I dividing equation 2 by 3 both sides, now equation 2 left hand side is what? Dy by dt whole divided by equation 3 left hand side means dy by dx equals to equation 2 right hand side is what? A cos 2 pi by lambda with bt minus x into 2 pi by 2 pi by lambda into what? B divided by equation 3 right hand side is what? Minus a cos 2 pi by lambda bt minus x into this is how much? 2 pi by what? Lambda. Now this cos cancel out, a and a cancel out, 2 pi and 2 pi by lambda is also cancel out. So see now what is remaining? Dy by dt by dy by dx equals to minus what? B. So only minus b will remain in the right hand side. Now this we just cross multiply. If I cross multiply, it will be dy by dt equals to minus b into dy by what? Dx. So which means this dy by dt is actually the particle velocity, and this b, as you know already, you have learned, is the wave velocity. Okay, and this particle velocity equals to minus wave velocity into the slope of displacement curve. This dy by dx is the slope of displacement distance curve. So finally children, the particle velocity means dy by dt is equals to wave velocity with minus sign into slope of displacement curve. Okay, so this is one of the relation between particle velocity and what velocity? Wave velocity. So with this, your chapter wave is also completed. So from next class we start new chapter, one of the important chapter under this particular unit, okay, and that is superposition of waves. And in that you learn about a topic called interference and bit. Thank you so much.